Hello. Today I will be tackling, I will be continuing from where I stopped last stream, um, with with trying to serialize the B tree with the table and yada yada, and fetch table, all that cool stuff, right? So, sorry. So, um, first of all, I changed a couple of things. Oh, before that, um, from last stream, I went changed back to how it's called, um, to Visual Studio, from vscode to Visual Studio. Let me move myself. Here maybe. Here seems but wait, does it block code? No, it does not. Okay, so. Ooh, lost my train of thought. So, okay. So I went from VS Code to Visual Studio 2022 because, well, it's just easier. I'm on Windows. I'm streaming on Windows, so I'll do it like that. Uh, so in the GitHub, in the GitHub repository, I added branch that is for the Visual Studio. It's tracking the Visual Studio one. It probably will be the most relevant. Like, I don't know how the main one that I was working on. I don't know. I'll try to update it because at the end of the day, it's just code. So I'll try to update it, but the problem is I don't know how I'll be doing with testing. I hope something that works in Visual Studio 2022 will work on VS Code. I will actually be uploading from my Ubuntu machine, from my laptop, the updated code. I'll try. I don't know how that'll go. So that's one. So if you go to the GitHub repository, go to the Windows, like there's a branch. Main is the Ubuntu one, and the one that I'll be streaming from now on is how it's called. uh, how does it called? I forgot. Something Windows. Windows main or main Windows, something like that. Because yeah, it that's how I'll work from now on this project at least. And second thing is I changed some code. Not a lot. I don't know if I need to. So yeah, okay. So I changed, if I'm not mistaken, mainly B-tree. Again, I know. So now instead of just holding integers, it holds a pair of int and size. Now, when I'm inserting a table, it's given a key, but I'm inserting like with like inserting keys and splitting and all, it's still just around the integer part, like the key part. But it also stores like each key, which key corresponds to tables, right? So which key is also stores the size of that table. So in bytes, it stores it in bytes. Yeah, in bytes. So my idea is store the B tree like serialize the B tree, then serialize all the like insert the tables into the B tree, serialize them, and when I'm searching for a table, I'll be just like I'll find the table in the B tree. I'll know what amount of bytes I need to jump to my B tree. That's the idea. I didn't really thought that through. But the idea is that now, how exactly? Not sure. I mean, there's a way the what's it called? When I'm creating a table, the idea is stores it stores it in memory, like in stores it on disk, and so they are one after the other, and the keys are also storing order. So ideally, what will happen is I'll be able to, I want the table 3, right? The problem I need to, well, there is a problem. I need to go through and to know the size of 1 and 2 for that. I can change it. I know, okay. Instead of its size, I'll maybe be storing like the size up until that table. So find the table and I know where to jump. So that's the idea. Now I changed serialize and deserialize for the B tree. First of all, it's not static, just because it's more convenient. I know why it wasn't static. It was static to begin with, and all of the others. It's pretty basic-ish code. Like, you can like this is all of it from here. No, from here, like serializing the name, right, and then going recursively serializing the children. Just added here size, right, and this is serializing the children, so this goes recursively. The serializing is basically the same, right? Yep. So sorry for that. Okay. So nothing much here. I also added get table size, but now I don't know if I mean I do need that. But the size should be added. Yeah, the size should be added on insertion, not where is it? B-tree serialize. No, not serialize. Oops. Insert key. Insert key pair. Now I have the size. Now we have insert in full. It goes recursively, so I'm not sure. It doesn't go. No, I mean wait. mean, I can, I guess, yeah, I think I should store it on disk. I should store it in order, like not in order of insertion, but by the B tree size, sorry, by the B tree itself. So my right, so my idea is like store it in the middle of the file. Now how exactly? I mean, I'm sure it's not hard to do that, but certain split, insert key non full, and size, right. Hmm. So, okay, I should serialize it. Should I really serialize it each time when I'm serializing? Okay, I'm serializing the tree, and should I just serialize the tables, the order they appear in the tree? Right, right. Now, how would that be? Well, that'd probably be here, right? So each time. First, okay, first we insert the table. First we insert table at the B tree that I should always have, right? Insert the table. And then right, and then okay, insert table, and at the end maybe I reserialize, like I do. I'm not adding to the file, I'll rewrite the file. Not exactly rewrite, but I'll figure out something somehow how to insert the tree in the middle, right? I'll figure it out somehow. Okay. So I'm not sure if size is the correct way to go about it. Now that I think of it, like, do I even need? I mean, I can leave it and then delete it if I don't need it actually. But by the way, let me run it and you'll see it works. Right. So I know how good you can see it because it's not being looked. Okay, that doesn't help. Okay, I can. Right. So yeah, it works. Like I know the printing is not exactly best, but uh, yeah, this is the left child and this is the right one. I checked in debug. It's like the root is 3 and it got 2 children, each with 3 keys. Okay, so let's actually start with something. So again, DBMS, where I left off. DBMS ID name, sure. B tree, that's the table tree, okay. Do I wait? Okay, instead of I'm thinking how I'll be creating this. So creating a DBMS, usually I'll deserialize the B tree, right? And initialize the name and ID. That's in case it doesn't exist. Right. So sure, let's have this, and we also have a constructor that deserializes the DBMS itself, right? So I need DBMS, sorry, DBMS, stud, and include upstream. Stud serialization is in, right? Stud if stream. No, it's. I mean, I can check that actually. Deserializes in, yeah, and serializes out. Okay. Now let's move here. Okay, so out, right? Out. Let's have this done. Sorry, I don't know what I'm doing. Okay, so this is just creating a new DBMS, right? So instead, let's also add a B tree here. No, it'll instead of a B tree, let's add tables. No, it's okay. It's okay to be empty. ID, ID, name, and the B tree. A table tree. Sorry. Do I have? Yeah, I have default constructor which does what exactly? B tree name and okay. So table tree. Sorry, table tree. Should be a pointer. I mean, probably it's probably new equals new b tree. Okay. Now this okay, we have an outstream, so we just read from so out dot no, sorry, we don't serialize it, we deserialize it, which should be in. My bad. Right in. Yeah, we deserialize, so it's in. So that's if stream, and that's in. Okay. Now, oh my god, I pressed a button. I hope I didn't change anything. In dot read. Okay, first like the B tree. So, oh no, sorry. That's name It's ID and name, right? I didn't serialize, but we'll go with ID and name. So let's change it like int ID 0 string name. Okay, size t name length. Well, name length should go before name, right? So a in dot read a in dot read that's reinterpreter cast char star id size of id right, now name length, and now wait, first of all name dot resize name length. Now instead of this whole shtick, name dot sorry, name at 0 and name length. And let's not forget the b tree table tree table tree serialized in, right? Serialized in. And finally, we just do this ID equals ID name and table tree. So ID name and table tree. Okay, and this we just b-tree. Where is it? Do we have? Oh, we have a destructor, right? Yeah, we have a destructor. So what we do, right? Yeah, it's not green. So delete table tree. Okay. What's this? Using uninitialized memory table tree. New b tree. Now it's initialized. Yeah. Okay, and let's just we can serialize it by I can serialize it in the destructor, right? Yeah. Seems fine, but yeah. Why not? Let's serialize it in the destructor. So okay, so size t name length 0. That's m equals 0. So first full ID, right? So oh, the problem will be providing an out. Can I give DBMS? Like, can I give destructor what's called? Can I give the destructor I forgot English. What can I say? Oh, by the way, I hope my shirt is not too ugly. It's been in the wash too many times. It's still comfortable. Okay, so what was I on? About yeah, can I provide? Let's check. CP destructor with parameters. You probably can't see it very good. I don't know why it's like doing this color, whatever. What's that? Special check the parameters. So instructors do not take parameters. That's the exact warning of the above. No is a simple answer. This would make automatic resource management a significant bitch because you'd have to worry about what parameters. I mean, makes sense. Makes sense. So let's just add a serialized one. That's just a serialization and be done with it. Void serialize is good. O stream, OF stream out. Yeah, let's do that. I mean, I do still want to serialize automatically when it's destructed. No way? No. You know what? No, because the user is not touching this part, right? It should be automatic, all of this. So, okay. So serialize. We need to serialize a name length. The name when 0. Okay, so well, first of all, serialize the ID out dot write cast char ID. I cannot. ID isn't fine. Oh, DBMS. Right, so ID and size of ID. Right. Now out dot write. Yeah, let's just copy this. Name length. Okay, name length and now the name itself. Oh, sorry, what am I doing? Name length equals name dot name. Yeah, name dot size. Name dot size. So right, and now out dot write name dot c string name length. Right, and serialize the tree. So table tree serialize. Table tree serialize. Wait. Yeah. Table tree dot serialize out. Wait, there's a problem though, I think, because no, right, when I'm re-serializing, like I'm serializing, right, or how it's called this. I think, wait, no, I think it's fine. It will overwrite, right? Like, yeah, okay. It doesn't go to the end of the file. So it's just serializing it again. Okay. Now, when I serialize it, I can actually wait, I want to do like go by index, like go by table size, right? I can fetch the table size, like I can store it inside the B tree. Oh my god. I can store my table size inside the B tree, and when I serialize the DBMS, I need to say like where to jump to find the table, right? So so I don't need okay, I need the size of the tables, but I don't, not here. I don't think so. Okay. Let's actually try and add a table, right? Add table. Now that's DBMS. Okay, so the idea is the table the table got ID, right? So I can just go with IDs. Where is it? Sorry. Does the table? Yeah, table has ID. It's size t though. The keys are integers. That won't do really, because I mean I can change obviously, right? Is it hard to change? I don't think so, right? I mean keys shouldn't be minus. So size t, right? Size t. Let's also change all of this. Size t. Right now in here, size t key. Right, find median key is also size t. All size t. Also find key range. Okay, like I'm pretty sure it would still work, right? Non DBMS, sorry. 3CP. Size t, size t. What else? What else? Size t. Size t. I mean, it's not exactly the key, but you know, key. It's how it's called. I mean, I'm not serializing it, but I think still better because I'm using it as an index, so it's probably better like that. Also, I don't know why this is here. Like I have assert. That's what ChatGPT told me to, and it actually did. It did fix it, but then still it's again here. I don't know what. I don't know. I have no idea. Sure. I mean, that's print tree, but whatever. Those are sizes. I shouldn't use integers. Good thing in the serialize, I'm using what's called the name of the parameter, not I don't have to change here. Just need to, yeah, this. Okay, here is important. This is also important to change over here. Size t, important. This is less important. And is currently size. Okay, should be fine. I'll run in a second. Wait, can I build this and see? Let's see if it works. Like what I changed didn't. Okay, it's fine. Yeah, it still works. It prints, by the way. Here it prints the numbers below. It prints the serialized tree. So if it prints what I added, it's the serialization and serialization working. Okay, so add the table. Table to add. So we have ID. So we just where is it? Table tree dot insert. Okay, I mean, okay, size table size equals table to add dot get table size. And I should probably get rid of it. I don't need sizes, do I? Well, I'm already doing it. I mean, the problem is after adding the table, I need to update the size. Does the size really matters? Now I need to store sizes of them. Because I'm adding table and here and it's a bit confusing. I mean, add table, I'm just adding it to the B tree. I think I also have to serialize it. So let's should have, okay, it should have a vector, right? It should have a vector of tables that are currently deserialized. I mean, this does make sense. Table table R. Also, let's change the name table tree to rename table tree to table ID tree. Preview. Apply. Okay. So, boom. So table R, table array. Now, serialize. Oh, I have to add the and serialize here. I have to add. Oh no. I don't serialize this one. This one is local because sorry, I have something between my teeth. This is local, like local in the sense what's here is only what been like deserialized. Like I'm adding here, also this is size t. I'm adding tables only when I'm fetching them. I'm adding the tables that I fetched. Okay, so add table. Right. Yeah. Sorry, not in fetch. Here, right? Sure. Table size and table ID. I don't need to call anything. So, um, where is it? Sorry. So first of all, I add table R back table to add. That because this is pointers. Wait, no, that's a problem. Let's actually have pointers here. Let's have a pointer here instead. Right. Okay. So we have a pointer here now. Obviously, that's an arrow. Oops. It's an arrow. Okay. Now table arrow added and table ID 3 table ID 3 dot insert key, right? And this is table to add dot, where is it? Get ID, right? Get ID and the table size, right? Okay. So we have this. Or should I wait? Should I? I think because the problem is I probably want to serialize it here when I'm adding. I want to serialize it, so the problem it requests like an outstream. I mean, I can pass. Sure, I can pass an outstream. Oops. OF stream. Yeah, out. Right. And let's serialize it then. Let's do. And where is it? Okay, so out. And let's add it to that out dot sorry, not out dot table to add dot out. I didn't change it. That's fine. Table. It's static. I have to change it to non-static later. Serialize. I mean, it doesn't really matter, but yeah. Table to add and out. What does it want? Current step of table non-const qualified cannot be initialized with a value of. I mean, well, it's const. R. Yeah, you know what? This should be reference as this. Not a const one. Not a const one. What does do I have a copy constructor for a table? Where is copy constructor? Table. Table name ID. What? Copy table. Why do I need a name? Copy table already has a name. That's probably something different, internal. Shouldn't be public, though I don't think so, because table name. What does it do? Where is it? Let's find it. Table. Did I miss it? No. Copy table. Copy table, not primary key. Primary key name. Copy table, primary key entries. New column. Contents equals copy table.contents. What the fuck? Doesn't a copy table have? I don't know. Let's just. I'll probably delete later. Maybe it's even deprecated at this point, but where is it? It's probably on the table. Const table. Right, this, and let's add it here below this. Yeah, table. Okay, so we have inside here we have the contents, which is fine. Primary key. Primary key should point to the column that this point, but not to the same column, right? How should I go about it? Like I can scan contents again later and no. Like I have equal for column name entries. What the fuck? That's I don't think that's good. That's a whole ass Farvec is stud variant. I know how equal variants really works. Like it probably should be the same one, so no, variant should have an equal sign that is like an sorry, comparison operator overload that works good. So yeah, my problem here is the primary key, right? Like I want only to copy it. Now I need to have a copy here. No. Okay, I create a new one. Okay, yeah, I have an idea. It's not. Okay, column. Okay. New column. Right. Okay, so now where is it? Well, first of all, let's get the easy ones out of the way. So ID equals ID, so table. So ID equals table dot ID and table name. Table name equals table dot table name. right? And column primary key, right? So for const column call in contents, const column call in contents, then oh sorry, not new column, am I stupid? Column pk, I mean new, yeah, right, new column. I do want, yeah, I do want to create its own like heap placement, right? Where is it? So we have name and entries, right? So pk name, like I like that it converts the dot to an arrow. Dot is just faster. So pk.name equals a table primary key. No, wait, not column pk. That's primary key. Primary key. No, primary key equals new column. Primary key equals dot primary key. Primary key, right? So primary key dot name. That's his name. What? Oh, not table name. I'm on a table. Wait, not table. Table. Copy. Let's change the name to copy because I don't like that it's that. Sorry, I don't like that it's the variable name the same as the type name. Where is it? Table. Where's the constructors? Right, table. Copy. So copy dot primary key dot name, right, and primary key dot entries equals copy dot primary key entries, right, and in here column and check if call not equals I mean call equals primary key, I mean that, right, primary key, then a primary key equals call. That's really a problem because it's const, right? So not const. Okay. And let's see. Yeah, else just push back to the table, to the contents, contents dot push back a column. Yeah. I like that. Yeah, it's fine. Yeah. Okay, we have a copy constructor now. Right? Now, where was I here? Tablesp non tablesp in here. So I have table to add. Right. So table size Why can't I? Oh, right. Now, table, copy, yeah, copy equals new, sorry, equals, right, new table to add, right. So that just copies everything here, table ID 3. Oh, and now we push back, obviously, right? So table R, I mean that's table vec, but whatever, that pushback, copy and insert key, table2 dot, I mean that's already copy, right? That doesn't copy dot get ID. Let's, you know what, let's even add it here. I can even add const here, and const here. So now here I just change to copy everything, copy tail size, copy, no, not a dot, right? That's a pointer. Get ID and copy. Serialize. Wait. What? Reference to table non-constant call cannot be initialized with a value of type table. What if I do this? Oh no, this like that. Yeah. And eat. Okay. So to realize the table, I mean add table. I mean, and I can create an offstream here. I don't need to pass. Right. 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 I mean, I can change it any time. Not now though. Okay. Now fetch table. First of all, we we find the key. Now, and here also I need to know where the tables are. So we can in the constructor, I mean, path to the table, right? Yep, sorry, not path to the table, but path to the file where tables are stored. So ID, name, and string path, right? Yeah. String path to table. Hello, what's up? How you doing? Let's have this path table now. Now that we have a table, I don't need. Well, first of all, let's go to the here. the here section. And where is it? Name and path table. How long have you been writing C++? That's, I mean, technically on paper, from the first time I wrote my first line of code in C++, it's been a year and or almost a year, sorry. Almost a year, but for the past couple of months I'm like been coding like in C++ once a week because of college. Right. So yeah. So technically almost a year. Are you coding? Like, do you have any background? As I always need helpers in my streams. Where was I? Oh, here, right. Path to table. And so in here, in outstream, I don't need this anymore. Right? And I don't need this. So we just make ourselves stood off stream. And I just start learning C+ for game dev. Oh, that's cool. Oh fuck! I just realized my face blocks the chat. I'll put myself here. Yeah, that's cool. C++ game. So I'm guessing how it's called. Unreal Engine. Good luck with that. I tried the game dev. I mean, I like the coding part of it, but there's a lot of how it's called. There's a lot of things that I'll have to learn to actually make games like art and audio. Either that or spend a bunch of money so people make it for me, and I'm just not built to do all that. I'm just built for code. And I hope I'm not discouraging you, right? There's always a way. You just have to. It's okay. From my experience, game dev is like, from my experience, from what I try, like the coding parts are not too hard. They are, but not too hard. But it's compensated it's compensated by having other things to learn besides coding. Code more on C++ for Unreal Engine and hope to get a job. Naughty Dog. Are those? Wait, I mean, we definitely played their games, but let me check. Naughty Dog. If I'm not. Oh, Last of Us. Yeah, I didn't finish Last of Us 2. But yeah, well, good luck with that. It's sorry. I'm also trying to think, but good luck with getting a job at Naughty Dog. It probably won't be easy, but if you give it enough time, you definitely can. It's not impossible. Depends also on the market. Like, yeah, you have time. You have time. It depends on the market and a lot of things. Like, if there will be searching for employers, and if they are even, like, maybe they will be closed or something. I don't think so, right? They have strong franchises on their hands. I don't see them closing anytime soon. But yeah, it's a my advice is try to, like, look into other things like game dev, but look Like, don't just focus on one company. I mean, it can be your number one priority, but also like see what other companies are hiring at the moment, so we can get at least some experience. And yeah, well, good luck with that. So, where was I? Right, outstream equals, not equals, sorry. With the name, the path, sorry, with the path. So just, yeah, just path table and just on the iOS binary, iOS binary. Did I write it correctly? Or is it? Okay, now, oh, I have in my main. Stored iOS binary. Is there a problem somewhere here? Oh, what's that? Huh? Expected an opening. What the fuck? Did I? Huh? Here somewhere? No. What do you mean expected? Like, what the fuck do you think that is? What? No. This. This, please. What the fuck? I think it's just tweaking, right? Or maybe I did mess up somewhere. Forgot to close something. What's that? Expected a oh. Yeah, we'll see. Whoops. Okay, so we have this out, and now we can just use out here and out up close. Out close, and serialize, same thing, We have no, serialize is not the same thing. Whoops, serialize is not the same thing. So this realize though, also not the same thing. Yeah, yep, it's fine. Okay, now to the actually hard part. DBMS fetch table with a key. Now, the way I'm doing it, when I'm storing tables, currently it's by, how it's called. Currently I store tables by order of adding table, right? Now I think the key is actually okay. The key is actually changing this one. So insert ID3, insert key, and serialize, right? I want to serialize it by right. So if I go enough bytes, how do I pass, like, let's ask ChatGPT how do I open an sorry, that's an input stream, right? I'll never be like a more no outstream, right? Output stream, an OF stream CP from specific byte. OF stream from specific byte position. You can follow these steps. Open seek p method. Example bin ios binary, ios in, ios out. Seek p. Move the file pointer to a specific byte position. Byte 10. Okay, so where is it? Add table. Oh, yeah, after adding the table. Okay, after adding the table, I want to know where is it. Like, sorry, after adding the table, I want to know where is it in like the path. I want to get the actual path to the actual path to it, so I can know how many bytes are in the way. Also, so how to serialize? Wait, how to add contents to the middle of the OF stream? Open the file in both input and output mode. Read the const from the insertion point to the end into a buffer. Seek to the insertion point. Write the new content. Write the buffer contents back to the file after the new content. Wait, what? File name, new content inserted. And byte position 10 where you want to insert. Open the file name, okay. Move the insert position. Seek G. That's seek G and that's seek P. Okay, seek G 0. Stood iOS end. Stream position, file size, file telg. What the fuck is telg? Insert position. Read the contents from the insertion point to the end into a buffer. Oh, that's a buffer. Okay, buffer. Static cast. Size T. File dot read buffer data. Buffer size. Okay. Move back to the insertion point. Insert, write the new content. Write the buffer content back to the file. Right. So what's telg? I'm still confused about it, and I don't know how that constructor works. Static cast size t. Oh, that's just the size. That's just the size. So yeah, I'm starting the size of it and then read buffer dot. What's buffer dot data? Like what's vector dot data? Good vector data. It turns the pointer to underlying array serving as the element storage. The pointer is such a range data. Oh, okay. Fine. So buffer.data. I'm reading file buffer.size. Wait, no, how did I? Oh, okay. I think I get it. So first of all, we insert into the table ID 3. Now, for actually serializing it, I need this in, as it told, F stream, right? So that's a pom iOS binary in, iOS in, and iOS out. So those are pipes, right? Right. Stood iOS in, stood iOS out. Right. Whoops. Like that. Okay. And that's That'll be file. I just got file. Fuck it. File. File. Popom. Popom. File. Table size. Okay. Now, obviously not just serializing this. I'm gonna. According to ChatGPT, I mean, why wouldn't it open, right? Okay? Let's thick G and tell G. And then there are member functions ifstream and fstream in readme that are used to manipulate and retrieve the position of the get. I mean, SafeG is used to move the get pointer to a specific file. It can be used in two main ways: the pointing, relative positioning. TLG is used to get the current position of the pointer. It returns the position as a stream POS value, which represents the number of bytes from the beginning of the file. Okay, so file if stream binary. Move the pointer to the 10th byte from the beginning. Get the current position of the pointer. Position. I mean, you know you moved it 10, right? Position. No, I don't get plus. Current position. Read the next byte. Character position. Position. What get? See. Okay, the file example.txt is opened in binary mode. Get pointer is moved to the 10th byte from the beginning using seekj. Current position of the get pointer is yeah, but what's the output? It doesn't. Oh, okay. So again, seekj moves pointer to a specific position in the file and move the pointer, and tellg is used to get the current position. Right. So in here, move the insert position 0 lg seekg insert position. Why is it 0? Wait. Insert position is 10. Right. Okay, seekg insert position iOS BEG. BEG. Can I wait? Can I answer this one? Copy. Address. No, I just want him to. I want to like respond to this. Okay, so for my previous prompt, what if the file is in binary? Is it still the same? iOS send tell G. That's beginning. Yeah, that's the same. That's the same. Right. Okay. I mean, I'm probably have to look at that a lot of times. I can go back to that a lot of times, but I think I got the point. Okay, I got the point. Probably. Maybe. So. Out. Okay, so now we want the insert position. What's the insert position? The insert position is key. Sorry, I'm just... So it is in order. Gotta be in order, right? Wait, I still have to... Do I have... Yeah, different tables of different byte. So yeah, I need to... Okay. Let's go to here. And in b3, let's have this. Size t. Calc bytes until key. Let's until key. Size t key. Okay, and in here, before the serialize, right? Let's here insert key, right? So here b3. So let's go. Where is it? Gonna. Oh, sorry. Kind of tired today, but I want to finish the stream, which will probably last half an hour. I want to keep it actually watchable length. I mean, 2 hours is still a lot, but not 5 hours. So, where was I? Right. So I'm just searching for the key. I'm searching for the key. So, size. Wait. Size. It's gotta be recursive. So I need to pass it and to pass it here, right? Right. Now I can just plus equals, right? This. Or static, I mean static. Static size t. Path size equals 0 right now. Okay, and now size ti equals 0. While I is less than I is less than current key. Oh, wait, that's a b3. So I'm starting with the root, obviously. Right, I can do what I did before. Where's it? b3? I have calc bytes. Now I can. I mean, I need to pass the key, but I need to. Right, in here, key and node, parent node. Yes, okay. So, while I is less than root current key size, current key size, and path size. Sorry, not path size. And key is. So I don't need static, right? Okay. And key is less than root keys at I dot first. That plus I. Okay, and I less than root keys I first. Okay. And when I find this, I find it so path size plus equals path size plus equals. Oh, wait, first of all, path size. And to check if the key is equal, right? If key equals to this, then return root keys I dot second. Okay. If it equals, no, what now? Again, the expression 0. And I'm guessing it's this. I guess I can. What if I do 4? 4 I equals 0. I is less than root parent key size I. If root dot keys at I dot first is bigger equal than key, then I break thanks. And now what's param 1? Like, what does that what does that mean? Oh no, issuing one while true and not issuing one for. It's not while true even. Fuck it. I'll leave it at that then. Works, it works. It doesn't matter. Okay. Now I found the one that is. Right, so I need and children at I minus 1. Now if I found, like, if it's less than the first key, so that's the first child, right? I'm always confused about that. Well, let's say we have 1, 2, 3, like 1, 2, 3. Let's say we have child like 0. Well, actually not 2, 4 and 7, right? 0. I don't know, 3 and 5. Okay. Not even like the B trigger, so oh wait. Yeah, the children are 1 less than the keys, are they not? Or is it max keys 4 max the key? No, the children more than the keys. Right, each one has a more or less. Right? sorry, this should be like that. That's 0, that's 2, 3. Right? 0, that's 2, 3. Actually, I can just do that. It's like 5, 6, right? Sorry, 5, 6. Or to the right of it, it can be larger. So key equals root keys I first, turn root keys I second. That's now I'm searching. Oh, the key is less. The problem is it can be, can't it? It can be more. Oh wait, that's, yeah, I should check if it's between the ranges. So start with I equals 1. Why? Why? I starts at 1. Oh, what if I only have one key? I should start at 0 then, I guess. Okay, while I is less than current key size minus 1, and I is less than root current key size minus 1, and minus 1. No, it was fine all the way here. I'm stupid. I'm telling you. And key is less than root keys I. It was fine the first. Plus I. If it is equals, and first, if it's not, then, well, first of all, then I have to update. No, the path is the second. Okay. Key less than this. Now I want the children that is either to the left of, to the right of this, or to the left of this. If it's 5, how do I know if it's to the right of this or to the left of this? Yeah. If it's 5. 4. Right, I can check. Wait, I can check the first one from here, right? I mean, how did I do it with find key range left? Less than current key size and key bigger. I search for it's bigger than current node keys at I first. Well, it's bigger. If it's less, oh, that's wait. Yeah, I mean, I need to check with the rightmost and leftmost. So where is it? Rightmost and leftmost. I mean, I can call this, right? Like return, I mean return it. Return calc bytes until key. key, and current node is the root at this point. I mean, sorry, root. I mean, I don't know if that's a good practice, but I'll do it like that, just so I didn't have to, like that. Current node, current node, current node, current node, current node, and that's static. Static size t path size 0. Of course. Oh, turn path size. Right. So now which key path am I taking? Like, okay, if current node keys not current node children. Yeah, current node children at this point I is this point it's bigger or equal, but bigger, sorry, it's smaller. Key is smaller, so right, well, key is smaller, and now it's not equal. I already checked that, so it's bigger than current node keys at first. So if it's bigger, then I'm checking it's bigger. I'm thinking about the how it's called, so I won't have off by 1 errors or something like that. So if it's bigger than this, then right, bigger at what's at I. Right. So what's at I is well, it's smaller. From left to right is small. So shouldn't be current keys at first smaller than key? Right. I think smaller than key. Current node keys I first smaller. Well, it's smaller than key. And okay. Smaller. Now it's either equal, but we check that. So if it's equal, it's returning the path size. If it's not equal, means the key is smaller now than this. Like the keys at I first, it's smaller. That means, okay, where's my example? Okay, let's say this is 5. It's 5, and let's say this is 6, and this is I don't know, 8, 9, 10. Okay. I mean, sure. So let's say I'm searching for, I don't know, what's between, let's have 8, fuck it, let's have 8. So 6 and sorry, and 7. Right. So I'm searching for, let's say I'm searching for, sorry, 6, and let's say 6 is at 5s, okay? No, at 5s. Okay, so 6. I'm searching while key is bigger than this. Sorry, key bigger than this. Yeah, bigger. Yeah, I know it. Now it's smaller. Now at I is 8. So I needed to check if it's bigger than, I mean, it is bigger than 5. But what if I have 7 here? It can be to the left of this? I don't think so. So I minus 1 is the 4. Yeah, I minus 1 is the 4. So I minus 1 dot, no, children dot key. If this is keys at last, like last of them, so keys at current node, children at current node, current key size. My God. So I'm kind of confused. I didn't touch B3 and I'm pretty tired. It shouldn't be really hard. It really shouldn't be hard. Problem is, I kind of forgot how B3 works, I guess. Right, so, okay. So, child, okay, I think I remember. I don't need if, so I don't need this shit. Child, how it's called? The child index should be just I, right? Yeah, I for some reason assumed that each of the keys have its own children. No. It's just aligned the same. So now I did check if key is bigger. I think maybe I should return to smaller. Well, it's small because I remember how to work with that. So if it's bigger, right, and yeah, now I need to, okay. So what I'll do is key is smaller than this, right? Smaller, while it's smaller. Now if it's okay, if it's bigger, then in here, say, let's do that. Right, so if it's bigger than 4, the I will be 3. So 0, 1, 2. Right. And if it's smaller than 8, still be 3. So I have to I minus 1, right? All right, I minus 1. Oh, sorry, that's not 3, that's 2. 0, 1, 2. 0, 1, 2, and that's 0, 1, 2. So I did correctly the first time, like with find leaf. I can erase that. Okay, so if, not if, sorry, current node, sorry, first one taking the side, which, yeah, which key I'm taking. So child, like from what child I'm taking the path from. So I'm guessing what key I'm taking the path from. So I should. Okay, I know what's confusing me. I should add the sizes to the nodes size up until now. The problem is it's because of the shifts, the size should change all the time. Now, if I take the keys, take the keys. No, I think it should work, right? So if I take, like, I have to decide what path I'm taking from left key or right key, right? It should be the same way I'm storing them, like inserting, right? Where is the insert? So if I, where is it? Print known, split children. Insert and split. So there are no ifs though. Yeah. Where's the regular insert child? No. Split children. No. Insert key on full. So insert key on full. While I has been 0. Plus 1 equals. No, wait. Okay, it should be the way I am. Let's just fucking do it and be done with it. So let's path size here. It's static, right? Yeah. Let's just path size d path size. This and here is it is equals 0. Okay. What? Where is it? Should this be equal 0? Oh, I didn't fucking. Huh? Ah, yeah. That's not here. That's here. At node path size. No, I shouldn't be like streaming anymore today, but I want to finish this. Like I'm not gonna finish, but you get what I'm saying. B3 right. Path size equals 0. Int I. Turn path size. Keys. Wait. Wait. Let's work that way. Okay, fuck. So if it is equal, turn. No, yeah, I do return path size. Now if it's root, I need to update the path size before it then. Right, so path size plus equals current node keys I dot second. Okay, and in here so it's smaller, then now it's bigger. So at I just return a calc. That's not a static one. Should that be a static one? I think that should be a static one, right? Because no, I'm calling it on a bit tree, but this. Right. Maybe I should add it to the node one instead. Because wait, return this calc math blah. I'm just putting in here current node. Right, sure. Turn this calc bytes until key. And key current node children at I and path size. Right. Wait, that's it. Return I need to make two checks. First of all, if I equal so if I equals 0, then turn I'm still returning 0 if it's here, so key is less. Wait, what if key is less than the first one? Like it's less than the first one, then I'll keep going. So I'm gonna check that here. If key is wait, what the fuck? It's less than this. Right, how do I know if I want to go like left, like it's to the left of the first key? It's gotta be less than the first key. Oh my god. Maybe it really should be bigger. Yeah, well, it's... Then what about the other end? Well, it's bigger than this. What about the other end? And if it's still bigger, then... Yeah, okay. Now it's not a problem. If I is... So if I is bigger than a node max children should, yeah. Max children. No, not max children, sorry, if it's null. If current node children I no current node children size equals 0, then turn 0. Right. Okay. I can set it to root, right? Yeah. Fine. And where's the... Oh. Yeah, sure. Okay, that should be good enough. Now, back to what ChatGPT told me. Oh, wait. Right, so the way I'm inserting the... Where is it? Yeah, here. So, insert add table, serialize, add table, right? So add table. And now I need to find and yeah, here. And to find its position. So copy the table size, insert key. Right, and after inserting, I can or is it size t file position equals table id tree dot bytes and table key copy get id. What? Right. Just the key, right? Is that just a key? Yeah, just a key. Now I have the position. Now I insert it in position. So yeah, open file. Blah blah blah. Move to the end of file, determine the file size. File tel g. SIG 0. What? Where's SIG? Position. Is used to move to get a bunch of specific position in the file. It can be used in two main ways. Move relative to current position. So relative to 0. So move relative to 0, like to the beginning. Multi-end file, determine file size. Moving get upon the absolute relative position to the beginning of the file. Oh, 0 is right. 0. It gets the pointer to 0 bytes away from end. Okay. And position tell G is tell G. Tell G is used to get the current position of the get pointer. It returns position as a string position, one which represents the number of bytes from the beginning of the file. Okay. So have insert position. I should rename it to insert position, right? Insert position. So right, file, yeah, file dot stick G. Yeah, 0 stud the iOS end. Okay. Now it says LG, so file size. Do I need a file size? And actually need a file insert position. Yeah, I need the file size minus insert position. Right. Okay. Jesus. So file stick G insert position. I was beginning. Oh, the insertion point. Oh. Okay. So file stud. Oh my god. What was it? Not SIGG, the other one, TLG. So stud stream pause. Stream pause. EOF equals file dot LG right. Oh, that's size, not EOF, not end of file. That's file size. So right, that returns file size until the end. Okay, makes sense, right? Now I need relative position. So size t. You know, first we file sig, right? File sig insert position and to the iOS bang. Right. Now against stream pause because it's still G, right? Sig G. Oh no. Yeah, sig G. Okay, so now I'm at position. Now I'm reading. I should read the contents to a buffer with size, file size minus insert position. Stud vector of R end of char buffer. There was a cast there, static cast, size D. Oh, that's true. Okay, so, makes sense. Static cast Oh, it'll probably be fine, right? Can cast by itself, but whatever. Static cast size t file size minus insert position. Oh, insert position is size t. Oh, it's stream pose. Then sorry, and just like that. So buffer and file dot read into buffer what was that? Buffer dot data, which I already forgot. Oh, right. Pointer underlying array. Right. Yeah, I need the buffer and buffer size. Buffer dot data. Buffer dot size. No, shouldn't be like that. Nope. Okay. Oh, that returns a pointer. Right. Returns a pointer. File read. Now, what we do is move back to insertion point of writing. Write new content. Write the buffer back to the file. Sick p. Okay. Data new content size. Okay, so file dot thick p. Insert position. Insert position beginning. I already have that, don't I? Oh, I read from it. Right. So again, insert position and stud iOS big as beginning. Now write to file dot write file dot write whatever content I want to add. Oh, yeah, and to serialize the whole fucking table. So table serialize copy the file reference type of OS stream non-constant qualifier. Okay, let's ask him how to turn f stream to off stream. File close. Stream file binary. Reopen the file with stood off stream. I want to reopen at a specific position. Read. Okay, so where was it? Sigchi, telg, sigchi, read. So that's O stream. And write is at the end. Write data back. So we start with off stream. out file, sigg, lg, sigg, out file, sigp. Okay. What? Oh, that's sorry. Offstream. Offstream doesn't have sigg. Jesus. That's a bit of a bummer. So reference type of stream and at non-constant calls I cannot be initialized with value. Let's do the stream. Okay, what if I just, where is it? Table HP. Serialize? Right. Static of serialize, off stream, just F stream out. Where is it? Serialize, column serialize, table serialize, F stream. Will it ruin anything? Oh my god. Oh, right. Okay. F stream. I'm not at the serializing. I'm only at serializing. Table serialize and column serialize is F stream. And in here I was column F stream. Okay. So logger out. Oh my god. I have to change so much. Fuck. There's gotta be a fucking way. Isn't there? According to him, specify to append. Oh, wait, I can OFS append. Okay. Want to create an off stream with pointer to the middle of the file. OFSICP position. File name binary and out. Studevs in, studevs out. Just out. Wait, what? No, there's problems here. Let's. Okay. This is fine. Everything's fine. Fuck's sake. Okay, file. Let's create an out, I guess. I mean, again, according to. Right? Wait. Do this? Nope. Of stream file name. Right. Move the right pointer to side position. Office.seekp. Okay. Stud of stream in path to table. Stud iOS binary and this. So that's sensors out. Sure. That's what it told me, right? I forgot the name. Out. And here, out seekp. Search position. I was beginning. I can make an if stream here. Yeah. Okay, so those are all if streams. And this is of streams. So seekp serialize out. Right? And now just serialize the vector back. Where was it? Oh, you read from that. So OFS out dot right data, right? So buffer, not buffer. What am I doing? Buffer dot data buffer dot size. Let's rename it to in. For DBMS, yeah. Apply. Okay. Out close in dot close. Okay, so added a table and fetch a table key. We just count bytes until key. Again, I need to count size the fetch position equals was label ID 3 dot count bytes until key. Right now we just fetch position. Oh shit. No, I think I remembered, but size key fetch position. Down 3 calc bytes until key. And now stud. Again, that's fetch tables. That's deserialize. Deserialize is in like if stream. So stud if stream in again, wait, in is for reading. Yes, I want reading. So in stood, no, not stood. In fetch table again. I need path to table. Sure, stood string path to table. Table and all that shenanigans. Member. It's not a type name. What do you mean? Not stood string. What the fuck? Yeah. In and now we. Sorry, I need to copy that into here. Position. Pa, pa, pa. Now in is seek. Sorry, in seek G. In not seek G. G from 0 to CG insert position. No, insert position. Insert. Sorry, fetch position. Stood iOS bag. And this serial table, the serialize name, string name. The fuck? The fuck am I serializing with a fucking name? Just give me an if stream. In. Or is it deserialized? Oops. To diff stream in. I don't need that. Oh yeah, I'm doing the name here. It's fine. What about the column? Column deserialize. Where is it? Deserialize column in. Right. In ID. Does it still work? Or is serialize? Serialize table. Yeah. First of all, wait. First of all, we have name length. No. First of all, we have ID, then name length, then name. Primary key. Okay, we're almost done. So table deserialize in. That's in, and now it's supposed to return. So table table fetched table equals to this, and or I just can return it. Yeah. So I return, and we have the table without looking through the whole file using a B-tree. I think that's it. Is it it? So fetch table, we get the fetch position obviously. In path to table. Was binary in out. Fetch position beginning and serialize. And I'm passing in like wait 6G. Oh. Wait, I need tell G. Tell G is the 6G moves the pointer. No, it's yeah, it returns. I need to read out 6G. Where is it? 6G. CP reference sets the position of the next character to be extracted from the input stream. Okay, yeah, so that sets the position of the next character. So, yep, we have fetch table, add table. I'll have to test it, but that's next stream. Probably. Definitely. So next stream will be testing this out. I mean, it's probably not working as is. It's never is working on first try, right? I have but the idea works. I mean, I'm finally down with the idea. Like, took me a lot of time to think like what kind, like exactly how to make it work. So, in short, what I'm doing is I'll have where is it? Let's show all the files. So we have yes, we need to create another what's called folder here for certain folder. Yeah. Or more like I'm thinking about the structure, but the idea is the DBMS. Yeah, where is it? This. Okay. So the idea is DBMS stores, I mean, info about the data about itself, not this. This is the current, like, this is tables that are currently fetched, right? Which does, yeah, okay, so it reminds me, I do need to add it to tables fetched, not just returning. So result, let's go, result equals this, and we'll return results. Oh, and close. Oops again. This and close if in dot close. I hope it doesn't close it B-tree. So yeah, the idea is serialize the B-tree, the name, and calculate the path, calculate where the table is using the table sizes that I store along the keys, right? And I mean, when I'm adding it according to the B-tree, so it's stored in a B-tree structure in the file. And when I'm fetching, again, I'm searching for key is supposed to be unique, right? So I'm searching for it to fetch position. So what path do I need to take? Create an if stream, find the position I need to insert, not insert, position where it begins, like where I need to read from, and deserialize, close, and return the result. And I did that, but I forgot to push back. So sorry. Result, how it's called, table R, table R, push back, result. Right, makes sense. So next stream I'll be polishing this code for sure. Not this, sorry, this, I think this is fine actually. Polishing this one, like serialize and deserialize of tables. And I mean changing some more, maybe even refactoring, like not refactoring but moving it a bit, because 500 lines of code and I'm not sure that everything's gotta be in the same file. Like, I mean, table and mostly of them table and column, so I don't know. Maybe erase some code. For example, this I don't really need. I don't think so. So yeah, so next stream I'll make it work, like test it, make it work, see that it works, and then I start on the final part, which is syntax, like being able to read the syntax. Not to read, sorry, being able to parse, being able to parse the syntax. So I'll actually have, like, you know, like in MySQL, you know, like add to table and stuff like that. Also, I forgot, but I do need to include in the B tree a delete option, because it's still not here. I will do it also next stream, and then start on syntax parsing if I'll have enough time. So, yep, that's it for now, for today. Thanks everyone for watching, everyone for tuning in. And again, the GitHub page for this, it's like, this is a Visual Studio version, not the VS Code. It's more up to date. It will be more up to date. So go to branch, Windows main, if you want to. I mean, you can do whatever you want with this code if you want to. Fork, use it for whatever you need. It's like, I'm not copywriting it or anything. If you have any questions, feel free to leave them in the comments or send me, I don't know, through GitHub if that's possible. I don't know. And I'll try to answer them. So, yep, again, thanks very much for watching, and I'll see you in the next one. Bye bye.